Okay, so for example 5 and 6, we'll look at multiplying by a constant other than 1. So any number larger or smaller than 1. So f of x, let's just keep it simple this time. Let's do x squared. And then for 3x, so notice I'm multiplying the x times 3. So I need that 3 inside the function operation. We'll do 3x. And we should already have the parent function values known pretty well. We have 4, 1, 0, 1, 4. Okay, so now I just have to multiply 3 times our x value before I square it. So a negative 2 times 3 is a negative 6. And 6 squared is 36. A negative 1 times 3 is a negative 3. Negative 3 squared is 9. 0 times 3 is 0. 0 times 0 is 0. 1 times 3 is 3. 3 times 3 is 9. 2 times 3 is 6. And 6 squared is 36. Okay, so I'll just take our points and graph them. So negative 2, 4. Negative 1, 1. 0, 0, 1, 1, 2, 4. So get our function that looks like that. Okay, so most of these points are going to be off the charts, but we know that 0, 0 is there. But then at 1, we're already outside of the graph. So our function's growing at a really rapid rate. Okay, so how could we describe this? Well, the terms we're going to use in this class is that it horizontally shrunk. So we took all of our values and pushed them closer to the y-axis. So multiplying by a constant, if the constant is greater than 1, like 3 is going to horizontally shrink our quadratic function. Okay, so now let's look at example 6. I'm going to use the same parent function. Let's make it easier. But then I want to multiply the entire function by 2, or the y times 2, so I'll do 2x squared. So let's fill in, actually let me do that in another color so I can easily distinguish it. So negative 2 we already know is 4, 1, 0, 1, 4. And if I just multiply the y's by 2, I'll get y2. So 4 times 2 is 8. 1 times 2 is 2. 0, 2, 8. Okay, so I'm graphing it. So a negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. There's our parent function. Okay, same thing. We know we have a vertex at the origin. And at negative 2, we're actually going to have 8. At a negative 1, we have 2. 1 we have 2, and at 2 we have 8. Little off there. It's kind of hard to draw with this stylus. Okay, so it looks really similar to what we got in example 5. So what kind of language do I want you to use to describe this? Well, if we multiply the entire function, or the y times a constant greater than 1, I want you to call it a vertical stretch. So notice all of our y values were multiplied by a constant, that 2. So the function was, or the parabola was stretched vertically. So for example 6, we'll say a vertical stretch. And if it's x times a constant, I want you to call it a horizontal shrink or stretch. Okay, so remember we've talked about all this before. I am going to ask you to do a diagram. We've done a diagram before, but so make sure you come to class ready to describe how the different parameters will transform our functions. That's what I expect you to learn from this.